Great. And now we are going to talk about simulators and simulations in robotics, because simulations are a very important point in robotics, and we need to use them for practicing before we apply into the real robots. And one of the points of simulations is to create plugins that allow us to extend the capabilities of the simulator. And in this talk, we are going to talk about this, how to create plugins for Gazebo simulation. So our next speaker, Shantanu Parab, is a teaching assistant at University of Maryland. And today, Shantanu will be talking about ROS to Gazebo custom plugins. And especially, he will be teaching us how to create a plugin to simulate a conveyor belt. Welcome to join Shantanu to the stage. Hello, Shantanu. How are you doing?
I'm doing great. Thank you so much for the introduction, Ricardo.
My pleasure, Shantanu. Everything is ready on your side?
Yes.
Are you easy? So we have some stressful situation preparing with the connection and so on. But are
Oh yeah,
you
I had some a connection issue with the password, but I got it figured out. So I'm
ex-
ready now.
okay? Okay, then can you share please your screen,
Sure.
and then the stage is all yours.
Okay.
Let's go.
Hello everyone. My name is Shantanu Parab. I'm a teaching assistant at UMD, and also I'm an intern at ROS Robotics. And currently we work on the Aloha kit, and we develop kits for research purposes and mobile manipulators and etc. So yeah, it's a great work. You're working with the robots, and so let's move on to the today's talk, which is creating Gazebo plugins. And let's first start with the introduction and why do we need it. So while working with Gazebo, you'll often and connecting it with ROS, you'll often come into some situations where certain things are not possible. Like one example here is the link or the joints that are used in Gazebo are quite limited. We don't get something like a conveyor pulley joint, and we are limited to prismatic joints and other rotational joints. So, what do we do in such cases is we utilize something called as plugins, and that run in background to make some changes in the simulation environment that will help us to get through the problem that we have. So, here in this project, we will be working on something called as a conveyor belt. A, a conveyor belt essentially is used for pushing your objects from one end to another and is used in factory settings. So here in this project, we'll be developing one such conveyor belt plugin, which can be used later on in any of your projects. And hopefully you'll get to know a lot about writing your own custom plugins. And let's dive into the objectives and how are we going to set up our entire workspace. So currently you will be having an entire project workspace like this. Also, yeah, so I'll be switching between tabs frequently. Like I have opened three tabs. One is for the notebook, one is for the IDE, and one is for the terminal. So just I'll let you know, and so that it's easier for you to follow along. So yeah, in our workspace, the IDE, we'll be having our ROS2 workspace. Inside our ROS2 workspace, we have our package that is called as a conveyor belt package. And inside that package, we have include folders, the launch folders, meshes, scripts, and other folders. So in for this particular demonstration, we'll be just focusing on a few things. That is the include folder for the header files. Next, we'll be moving on to the source folders where we'll be writing the CPP file for our project. And the rest of the templates are already there, so you don't have to worry about launch files and etc. We'll be talking a little bit about CMake list and package XML. Um, so next, the objective would be like setting the package up. Later, we'll be doing something called as establishing a connection with Gazebo, so that we get an idea of how Gazebo is running in the background and how our code reads the Gazebo environment. Next, we'll be utilizing the model that is in the form of a URDF, and we'll be figuring out how we can extract joint information or other link informations from that SDF or a URDF model. Once we are done with that, we can also do certain stuff in the URDF, that like passing arguments or parameters to our plugin. This will be helpful in certain cases. I'll go through that as well later. And then we'll be talking about how can we simulate motion in our robot, or in this case in our conveyor belt. And lastly, what we'll be doing is, since every time we work with Gazebo, we have to work with ROS to a certain extent, and adding ROS functionality to your Gazebo plugin would be a great advantage for all the ROS developers. So that's how we'll be adding a small topic subscription to our Gazebo plugin, so that it can help us to connect with ROS as well. So you can see this GIF that is here, that tells you about what we are expecting from our project. So we'll be having our conveyor belt working. We can turn it on, turn it off, and then we can also spawn a certain object on it, which can you can see it would work flawlessly. Before moving on to the details of the project, I would like to highlight a few resources. Like this, I've listed a few resources that can be helpful for you to learn beyond this project. So I'll highly recommend you to follow the Gazebo API documentation if you, right now, if you have time. So you will come across some classes and pointers and other things that might be helpful to understand the code later on. Also, here in this code, I'll be following something called as a PIMPL idiom implementation from C++. It is essentially just hiding the implementation into the source file and keeping the header file as empty as possible. This allows us to like build bigger libraries. So whenever there is a small change in our code, we don't have to recompile the entire library, and it saves a lot of overhead timing while compilation. There are a few other plugins that you can look through and check out later after this demonstration is over. So let us now start with our simulation and look at what is going on in the entire thing. So in order to start your simulation, you have to first set up. Uh, so I'll just copy this quickly, go to the terminal. I'll paste it here, and I can source my environment. So that's done. Once that is done, I have to go into my workspace. So that's the roster workspace. Next, we have to build our package. So our package is called the conveyor belt package, and we just paste it here. It's easy. I guess we have to wait for a little while it builds. Yeah, it started. So the first initial build would take some time because it is going to build everything from the scratch. But later on, as we just go on adding one stuff at a time, it would be faster. So now we have a clean package that is built, and hopefully everyone is on board with this. We have to source the environment again, the new setup that we have done. Once that is done, we can start with our launch file and we can launch our simulation. All these launch files are already there, so you don't have to worry about how it works and what goes on. There will be different tutorials for this. So our focus here is working with the plugin. So once you start this launch file, hopefully you will be able to see a conveyor belt spawning in an empty gazebo world. Okay, I think. Okay, yeah, it's taking some time. Yeah. Once the Gazebo environment boots up for this application, I think it's easier for it to launch. So now you can see there is a Gazebo environment with a conveyor belt inside it. But let's see what happens when we spawn an object over it. So let me just jump to the notebook once. And this is our script to spawn an object. So what we'll do is we'll go back to this terminal, the terminal that we have. We'll open a new tab over here. Uh, so before running anything in a new tab, it is essential for us to source the ROS environment. So that is what we'll be doing. So we go here, we paste this. Once we have it here, what we'll do is we'll spawn an object. So copy this spawn object on the belt command. It will run a script in the background which spawns an object on the conveyor belt at the exact place where we want it. And, and in our simulation, you can see there is an object that has spawned on the conveyor belt, but nothing is happening over here. So we are not able to do a lot of stuff over here. So why is it not happening is because we don't have the plugin set up yet. So let's move on step by step and understand how the plugin works, like from the basics and how the update connection and everything works. Let's get into the juicy part. And for that, I'll first stop this simulation so that we don't have anything running in the background. Let's stop this with the Control C. Let's go back to the conveyor belt notebook. So here's our folder structure, okay? So if you can see, what we have to do is currently we will be having two missing files. One is the conveyor belt plugin HPP file, the header file, and the conveyor belt plugin CPP file. So these are the two files that we have to put exactly in the following location. So this won't give you errors in the future tutorial. So let's go ahead and make these two files. And in order to make these two files, what I'll do is I'll go here, I'll go into this conveyor belt, I'll click here, new file, and the name of our new file is conveyor belt plugin.hpp. Just so that you don't spell it or do some spelling mistake, make sure you copy it from here so it would save a lot of time for you. Next, the next file that we need is conveyor belt plugin CPP file. So these two files, we'll make it in the source. So conveyor cpp, right? So we have two files of that we require for designing the plugin. So hopefully if you have followed till here, your folder structure should look something like this. And let's go ahead and work on these files. So throughout this entire demonstration, the main file that we'll be working on is going to be conveyor belt plugin CPP. But before moving on to that, we'll set up a few things in the package. Like firstly, let's set up the header file. In order to set up the header file, you just have to copy this entire code from your, I'll explain this code in the IDE, and go ahead and put it here in this. So what this code essentially does is it creates a class called as a conveyor belt plugin private class, and it extends it with the Gazebo model plugin. So in this Gazebo model plugin, we have one standard method that is called as a load method, which we inherit from the Gazebo class, the model plugin class. This takes two arguments. One is the model pointer and one is the SDF. So we'll be passing our model, that is a robot, the conveyor belt, as a SDF into these two, and a model in the Gazebo model pointer. This is essential for us so that we can later on figure out which joint we have to pick, or what other transformations do we want to do on a robot. So here, as I said, we'll be using something called as a pointer implementation idiom. So we'll be using this private unique pointer that will be editing, and all the classes that and methods that we'll be creating with are going to be in regards to this, so that we don't have to change the header file again and again. So that's why pointer implementation is quite great for what we are doing, like creating a library. So once this is done here, we have a few common include tags where we are getting the plugin from the Gazebo common library, and yeah, the rest of the stuff will happen in the CPP file. So let's go back to the conveyor belt notebook. In this notebook, you can next you can see is we have to create a CPP file. In the CPP file, we have to add this code. Let's just copy this code and paste it in the ID in the conveyor belt plugin CPP. Okay, so let's understand what's going on in this code a little bit. So we are importing a few libraries, that is model, joint, and then we are also linking it to our header file. And then because we'll be using Gazebo with ROS later, we need a Gazebo ROS node. And since we are also adding a ROS functionality, we'll be using RCL CPP library as well. This is a standard message type that we are importing that will be used later. So these are just the normal imports that we'll be using later on in the tutorial. You don't have to worry about this. This is just definition of some for the looks itself, like it would be color coded, everything would be nicely colored. So that's why we need this. Okay, so yeah, as I said, in our class, we have to declare a constructor and a destructor. So here we are creating a constructor which would essentially just tell us that the conveyor belt plugin is initialized. You can use this to debug your plugins later on, like when once is your plugin started, or is there an error, and does the plugin break down. So that this is very essential. Later on, we also have the destructor to know that our plugin has stopped successfully, and then we can end our program. And you will be seeing there is a empty load pointer, sorry, the load method. In this load method, okay, this is better. So this load method is essentially empty, so it won't do anything for now, and we'll be later on updating it to do our functionalities. So, and the important thing is to register our model plugin into the ROS environment. This will help our robot to understand where our model plugin is to be, the plugin is to be found at, and then it would link it to the model in the Gazebo plugin. So I guess everyone is able to follow this until here. Now what we'll do is, um, yeah, we have to update the CMake list. In order to update the CMake list, we have to make our plugin known to our compiler, so it compiles it when we build our project or the package. So for this, what we'll do is we'll copy this entire stuff from here. We'll go to the IDE. In the IDE, we have to go to the CMake list, and the CMake list would already have a lot of stuff over here. And since you're following the same project as me, you'll be having a line which says put the code copied from the notebook here, and this is where you have to just paste the entire code that you got. So let's just indent it correctly. And this essentially does is it adds the conveyor belt plugin as a library, as a shared library, so that it is available for all the other objects or the packages that you have in your workspace as well. We target this library to the conveyor belt plugin, and then we add some dependencies. For us, the main dependency is the Gazebo ROS, because we have to connect it with ROS and Gazebo. And then we'll be exporting this conveyor belt plugin. And how this is export work and why this is important is, let's first build this project. Yeah, but before building it, we also need to add this plugin to our URDF file, because our robot won't know which plugin is to be used, right? So let's go ahead and copy this. Go to your IDE. In your IDE, open the URDF folder. In this URDF folder, you will be having a conveyor belt URDF.zacro file. So what you do is you scroll down. This all this information is already there. It is just for the robots uh, dimensions and others thing. So once you have it, go here and paste it over here. You will already have a comment where you have to copy the code, and make sure you don't copy it below this robot tag, or else it would give you an error. So this plugin is where we are giving the file name. This is the file name that it is going to search in the entire workspace to figure out which plugin it has to use. This is the plugin name that we'll essentially see in the Gazebo environment written like as a name of this plugin, because we can have multiple plugins for the same thing, right? So we can differentiate using a namespace. Next, this is a parameter that we'll be talking later and how to utilize this parameter. Okay, let me just check if everything's going fine. Okay, yeah, it's good. So later, now we have to, since we have the setup done, we can go ahead and build our project. To build our project, just copy this, go to your terminal and paste it. Okay, so once, okay, let me see. Saved everything. Looks like this is saved. Okay, this is saved. Okay, let me see what's happening. It's not throwing an error at all.
This? Have you tried removing your build and install, Shantanu? I've seen you having
Oh,
some issues there.
okay, I'll just do it. Yeah, I think I'll just open a new tab, that new terminal. That should be fine for this one. Let me just source this environment quickly.
Yeah, that's what I was gonna say. You should compile in your package, in your workspace, sorry.
Yeah, I think, am in the correct workspace. Just correct me if I'm wrong. It says it has a
Maybe
converter.
you can remove the
Mm-hmm.
in build. And install also. Yeah, log is okay, yes.
Okay. This.
So you have some problem in your, let's see the path that says, okay, so now you close this terminal and open, first, before closing, wait.
Mm-hmm.
So remove again the build and install. And
Okay.
then close this terminal and open a new one. So it will have the clean source, just in case that something is wrong, because it looks like it's a problem. Not.
Mm-hmm.
And we can see now, yes, so you can do a source of opti ROS, yes, this setup. Let's see, and now try to compile again. Let's see if it works. Okay, can you just go compile everything? It is badly written, by the way. It's badly written. You have
Oh
a
yeah.
spelling mistake. Okay, so here, why is it making reference to the install? So what do you have you compiling something inside the one of the? So it shouldn't say anything about. Let me
Yeah.
see.
That's what I'm.
No. This is automatically generated. So yeah, you have another build,
Mhm.
another install there on the top level. I don't know what are those things. You better remove them on the
Okay.
IDE. On the IDE,
Okay.
yes.
Oh, I got. Uh,
Yeah, so this is wrong.
oh,
So I don't know what's
yeah.
this doing there. And then what I'm suspecting is that something is also in the in another directory.
Okay, I was able to get rid of this. This is empty. This is empty. Rid of this as well.
The, yeah, I see that you have strange characters in the code. You can see on the IDE line number 9, for example.
Those
Yes.
yellow squares.
Yeah.
Yeah. Delete those.
Yeah, you should delete them.
Think they're strange characters.
Yeah, somehow copying this created that
Mm-hmm.
those characters. Those characters. You need to remove them all from all the place.
Okay, this is quite strange.
Yeah, you should. No, wait. Yeah,
I can just
You can
control
try
F
copying
and
it again. Yeah, or this. Yeah, there you go.
you have to go to the right and then press backspace. Go to
I
the
think this
right
is
of the
fine.
line Go to. Yeah. Also, yeah. Maybe. Oh, okay. That was clever. Very good.
Awesome.
Yeah. So check the other files also, just in case that something happens also in the. Got the same error.
There you go. Yeah, those. Do the same thing. Great.
Yes.
Yeah.
And here is.
Okay, yeah. I think this
Well, you got
maybe
there
this is
too. Yeah. This is a copying issue.
Yes.
A lot of people are saying that they were able to build it, so this is most likely it.
Now you need to remove again. Yeah. Remove again.
I think this works.
Okay. Then.
Oh yeah, it was a copying issue.
Okay.
My bad.
Okay, we are back in business, I think.
Yeah, we're
Go
back
for
in
it. Go
business.
for it.
Sorry for that delay for
No, it's
the
okay. You
previous.
are doing excellent. So go ahead, Shantanu. By the way, we have 5 minutes. Okay, left.
Okay, okay, cool. I'll get it done
Go
quickly.
for it.
Hopefully this builds in time.
Yes, that's one of the problems. But in the meantime, you can tell us about some other
Sure.
plugins that you have been doing. What about other plugins?
Yeah, so okay, this I'll take that later.
Okay, okay,
But yeah,
great,
so
great.
if we have our build done successfully, so because this is already done, let's quickly jump to the sourcing of this, and then while that is being sourced, let's go ahead and jump to launching the. So we won't be looking into the simulation right now because it would take some time. So once you have simulation is correctly set up, you should be getting a line called as initialize the conveyor belt plugin. This essentially tells us that our code is right, our setup is right, and everything is good to go, and we'll work on this, the functionality and the rest of the stuff. So what we'll do is firstly we have to add a connection pointer because we have to update our code whenever there is an update in the Gazebo environment. So for that we'll be creating a connection pointer. Let's go ahead and open the cpp file. In the cpp file you have to go here and say public and then create some pointer. This is connection. Yeah, so we go public and we create a connection pointer. Once this connection pointer is done, we also need a method. Okay, so this method is essentially we go into the same and we create a method as well. So we have a pointer that connects to the update connection and the method that we'll be working with. What we'll do is in this method we will be copying this and let's write the method over here. Yeah, it's getting these weird characters when it's copying. Just keep this find command handy. So whenever there is an on update, it would say that a Gazebo world has been updated. Okay. Okay. There is one thing that I have missed over here.
We have to finish, Shantanu.
Okay. So what we'll do is we have to add on in our load class. What we'll do is in our load class, what we'll do is we'll add a implementation to this. And yeah, once this is done, we can also go ahead and quickly build this, and hopefully it takes less time. Okay, while this builds, we'll go ahead and we'll see what we have to do next. We have to figure out that there is a joint called as a belt joint in our URDF folder. In this URDF, what we'll do is we have to fetch that belt joint from as a joint pointer. We'll receive that pointer and store it in this joint pointer thing, and then we'll be acting on it. That is, we'll be implementing the search, like firstly we'll be doing a exception catch where we'll be figuring out if the belt joint really exists in the UID. If it doesn't, we'll stop the plugin and we'll send a belt joint not found, unable to start conveyor plugin. Once that is done, what we'll do next is we have to figure out the max velocity. So in order to get the max velocity, we'll get the parameter. In order to fetch that parameter, what we'll do is we'll set up some variables firstly. Once those variables are set up, what we next is we can get the upper limit from the joint that we already have. This would give us the max upper limit for the joint as set it up in the SDF file. Once that is done, we can also get the element from the SDF file, that is the max velocity element that is in this tag over here. This gives us the max velocity, and we'll store it in a file, in a variable as well. And then let's see if this is done building.
So we don't have time, Shantanu. I think that by you have summarized the points in there, and then the people can follow afterwards with the ROSject,
Okay,
continue the instructions, because still need so many steps to be finished. Yes.
yes, so I'll just go through this ROS quickly and then you can follow it later. So what we do here is we get the velocity element and we store it in max velocity variable. Once this is done, what we can see on our screen is the build package is done. We launch the robot. We can get all this information like the loaded model and the SDF. And we also get the max velocity, that would be 0.3, and the max joint limit that is set up by the URDF as 0.01. Later, we want to move the joints. In order to move the joints, we use the methods that are already given in the Gazebo API, which is like we get the joint, we use the set velocity method. This set velocity method, we'll be setting the velocity as the belt velocity, which would be here as 0.3. And then we'll be also figuring out what is the belt position from the position method. And once we get that, we'll check if this belt position goes above the limit that we have described. We have to bring the belt back to this original position. So what will happen is the prismatic joint would have a certain linear velocity. It would move forward, and once it goes beyond the limit, it would come back. So once it comes back, it doesn't bring the object that is spawned on the prismatic joint back. It's just the joint that comes back. So it keeps on moving the object forward in the time, as you can see in this video. So in the end, when we have to add a ROS functionality, what we'll do is we'll define a ROS Gazebo ROS shared pointer node, and then we'll also create a RCL CPP subscription to let's say we call it power subscriber, and we'll have a method that is a callback method that changes some variables in our code that stops uh, the conveyor belt. So
Yes, by
here,
using ROS, right?
yes.
Exactly.
So
So
here
we have to finish,
the node.
Shantanu. Please
Okay.
wrap up. Wrap up.
Yeah. So finally, when you are able to do all this, what will happen is you can get a conveyor power topic in your ROS topic list. Once this is done, you can send a false or a true signal to your using a command line, and it would turn off or turn on your uh, conveyor belt, and you can see some logging into the terminal saying the conveyor belt is turned off or the conveyor belt is turned on. So I think that's it for
Yes, we can
tutorial. You
finish
can
here.
follow it.
We need to
Yeah.
finish here, Shantanu. I
Yeah.
think that you
Okay.
have
Good.
prepared an
Thanks. This
excellent
was fun.
Rosette. So thank you very much.
Yeah. No
Thank you. So what's about this image that you are showing us now? That you were showing us
Okay.
this drone thing. What is this?
I think I should stop sharing
Yes, you
this.
stop sharing, but you can share it again if you want to let us know
Yeah. Sure.
about your image, what it's about. In the meantime, the people can put your question. Please put your question for Shantanu on the Q&A tab that is on the chat here on this side. So select there, vote for the questions that are already there, and then I will ask them according to the vote to Shantanu. let's go. We
So
have a
this,
few steps.
so
Yeah, go ahead.
meanwhile,
Yeah.
I'll just explain this plugin. This is also a model plugin. Here, what we essentially are doing is, once we know there is a joint, a link on a robot, we can fetch it and we can do a lot of stuff with it. We can add force to it, add torque to it. So what is happening in this plugin is we are getting the links that are connected to the propeller, and we are pushing it using force and torque, and then we are culminating the entire force and torque and putting it on the base of the drone, so it lifts the drone up. And after some PID and some other fancy control stuff, you can make your robot fly, pick objects, do a lot of crazy stuff. So that's how you can design more plugins and you can utilize the full power of Gazebo and simulations.
Excellent. And do you have the source code open for this also plugins
Yes.
in your
If you
website,
go,
right?
yeah, you can go scroll up and you will be finding some, yeah, in this itself, the drone plugin, and you can figure out like it would be similar to whatever we talked right now, and just a little bit of drone stuff in that.
Okay. Then let me ask you one other question because we have been working here. Can you show yourself so people can see yourself and then recognize you? Then on the streets and in the conferences, they will say, "Oh, that's Shantanu, the famous
Oh, I
guy."
think my
Yes.
screen,
So what
everything
about?
is
Yeah. Sorry.
visible.
Yeah. We can see you now. Excellent. And then Robert Gruberski is asking an interesting question is because
Mm-hmm.
you have been showing these plugins for
Mm-hmm.
Gazebo Classic, but what about
Yeah.
the using the same method? Is it possible to use the same for Gazebo Sim, which is the old Ignition Gazebo? So then Ignition Gazebo now is called Gazebo Sim, right? So
Mm-hmm.
so what is the difference between creating plugins for the Gazebo Classic or the new Gazebo?
I think the basics would be all the same. Maybe some methods or you can read through the API for each specific Gazebo environment or the Gazebo versions, but most of the stuff would be same. It would be a version up. Maybe it might be downgraded. One thing I noticed is there would be some changes like in the classes, like maybe it might be ignition, or in some cases it might be math. So in terms of those particular things which are very version specific, you can always rely on the API or the documentation given by the official Gazebo channels. That's what
Okay.
I would suggest.
Okay, and then Alexander Warkus has a question that says, is the workflow the same for creating custom plugins using Python instead of C++? Have you
Okay.
created Python plugins?
So I haven't worked with Python plugins because the majority of the plugins, whenever I have worked with ROS, are all developed in C++. Maybe that's because C++ becomes very handy while giving like sending out the plugins to other people. Like the libraries are quite easier to transfer, and which is a very difficult task in terms of Python. Like you have to set up the environment for the particular code to work. So I think I don't have exact knowledge about what goes in the Python plugin.
Actually, I didn't know that you could write plugins for Gazebo in Python. I thought that was only possible in C++, but
Yeah, that's my thought as well. I've never
okay.
seen a Python plugin
Okay.
anywhere in the ROS documentation so far.
Okay, okay. Then unfortunately, we don't have more time for questions, Shantanu, but
Sure.
it's going to be a pleasure. Also, the project that you have prepared is
Hmm.
excellent. Then people can that have the copy, then they can follow step by step and finish until the end and get the result. So thank you very much
Sure.
again, Shantanu.
Have a great day. Thank you.
Yes, thank you, Shantanu, very, very much for your Gazebo plugin presentation. Everyone, you should now all be seeing a box in the chat where you can rate the speaker. So please take a moment to rate Shantanu because, again, at the end, one of these speakers will get the best raw speaker award based on your votes.
So don't forget to rate. And before we meet the next speaker, we cannot miss the fun time.
Oh my word, fun again.
Yes. So another prize quiz right now. So the winner again will get this super sweat box with a I'm a robotic developer T-shirt, coffee mug, and the stickers. And this is sponsored by Nav2. So how does it work? The following 5 minutes video is about nav2. So at the end of the video, you will see a question related to it. And the first person who gets the correct answer in the chat will get the sweat box. So you may need to go to the page of the sponsor to get the answer. So now let's watch the video, and the next speaker will come back in 5 minutes.
See you soon.